So I'll introduce you to Dan Reddig. He is our product manager for all of the brands that you see here on this screen. As you can see, here's some pretty well-known brands in the market, but also know that there's a pretty good variety of boiler technology here. So this whole topic of cast to condensing is something we've had many, many times over the years with our customers and walked through this exact same process with them. So happy to be here today to share, what we know about this topic and help you through your own journey and hopefully make a connection with you going forward. So just a couple of housekeeping items here before we get started. If you do have any questions as we go through this, feel free to ask them. We'll be monitoring the Q&A section of the Teams meeting here. That should be in the toolbar up across the top of your screen. And if you type those out at any point, I'll be sure we catch those and hopefully make some time in here at the end to give you some of those answers. And also know that we are recording this webinar, just like we did the first one, just so that you and others like you can enjoy and utilize this content as we go forward. And we'll make sure we share this recording with you after the fact. So with that, I will pass things over to Dan Reddig.
Yeah, thank you, Charlie. As Charlie said, Dan Reddig, product manager for the three brands you see up in front of you. Been with the company about six months now. And prior to that, have worked in the boiler industry for another manufacturer for about 12 to 13 years. So really what we'll be discussing today is just kind of, more lessons learned, things that, I've talked to either manufacturer reps about, contractors, engineers, and just kind of, some speed bumps that we've seen, as an industry, as these technologies have been applied. So I see on the call here, we've got some manufacturers reps, we've got some engineers, but, I think there'll be a lot of topics that a lot of us can relate to that's, has been doing this for several years. And then if we're just starting off in the industry, there's hopefully this will be beneficial and it'll kind of allow you to think about some things and hopefully avoid some of the mistakes that the rest of us have made as we've kind of made this transition. So hopefully there'll be some benefit to everybody that's attending. So what we'll cover today is venting. I think venting is where we can get ourselves in a lot of trouble, just not understanding the different type of vent categories, the materials available. If you look at like sidewall vent terminations, every manufacturer does that a little bit different. So just to be aware of, if you're used to specifying one product and you move to another, maybe the clearances, the required distances will be a little bit different. Common venting. We've probably all got our own opinion on common venting, but sometimes it is something that needs to be done. And there's going to be different avenues for you to get there as an engineer or a contractor when you go to apply common venting. Gas pipe sizing. All the manufacturers are going to reference the National Fuel Gas Code. And then I think the biggest thing, and we'll talk about this, is right. How many times have I heard, well, the boiler had 1-inch gas pipe coming out of it, and then we see 200 feet of 1-inch gas pipe ran, right? That it doesn't matter whose product it is, that's not going to perform well depending on the BTU capacity. Regulators. This is a topic that, again, if we go back 10 to 15 years ago, as high efficiency condensing products started getting applied more and more in the market, as the turn down increased, you started to see some things with regulators. They just were not responding the way that the boiler manufacturers expected. So there was a lot of work going on between boiler manufacturers and regulators. So there is a lot more detailed information how to apply regulators today than there was, but still would like to talk about that. And just, the condensate management. So with a high efficiency condensing boiler, now you've got the condensate removal that you have to think about. So, how do you do that? When do you apply a neutralizer? And we'll just kind of walk through some of that. And then also what we're starting to see in the industry is a lot more of these condensing products get installed outdoors. So what do you do about that condensate if it's getting installed outdoors, especially if you're in a colder climate that is known to have freezing temperatures? And then we'll just have a recap, and then we'll open it up for Q&A at the end. So what we'll start off with is the vent category. So everybody, at some point has been exposed to, if you've got a forced draft venting scenario, or if you've got a natural draft. So if we think about like category one, that's going to be what we would say is our atmospheric. We got some pictures of some atmospheric cast iron products there. Pretty standard that we've all used for years. But what we've started to see now as we move towards the condensing products is we're going to be category four. So that's going to be a little bit of different what that vent looks like. And that's the big thing. Unfortunately, every boiler manufacturer has a horror story of where somebody has tried to apply a high efficiency condensing product that should be installed in category 4 venting. They've seen it installed with that Cat 1 B vent, which is not good, right? That's just going to tear up the vent and can cause a lot of cause harm to anybody in that occupied space. But again, it's something that every manufacturer has seen. And then on the condensing side, you'll see category 2 applied a lot to when people go to common vent those. They'll move that to category 2 for common venting. So that's kind of on the condensing side. The two that you're going to see is category 4 and category 2. Kind of want to walk through some of when you look at these manuals as far as vent manufacturers and approval. This is a headache that we've had as far as from the manufacturer side, because it feels like from our point of view that every year, right, there's a new type of vent coming out. So that requires, as a manufacturer, right, it doesn't matter if it's us or one of our competitors, when that new vent manufacturer releases a product, we've got to verify that it's certified. We got to open up our file, make sure that it's certified for our equipment. So it's got to be put in our manuals. So you'll see two sections here on the screen. These are approved stainless steel vent manufacturers from two different I&O manuals. So you can see there are some crossover between the two manufacturers. But then there's some that one manufacturer may have a certain product certified and another. So what this is, if you're working with a venting manufacturer to have a specific vent specified, just need to be aware that as you look at competitive equals to the product that you're designing around, they may not be approved for that venting. So when you go to approve that product as an equal, that's maybe something that has to be worked through on the back side as, okay, well, I've specified, well, just for this example, metal fab, right? We've specified that metal fab, but one of my equals doesn't have it. So how does that get worked through on the back end? That could be something that needs to be worked through if an equals allowed on the job. And you're going to see similar things with PolyPro. So here's two different sections from IOMs. So this is a little bit different. So you've got the top one there, the top listing for PolyPro. You can see you've got 4 manufacturers as an option when you go to use this product. But then if you have an equal or another product, right, that they've only got the Centrotherm and the Duravent approved. So again, this can be an issue if approving another manufacturer in that Z-Flex or that Eco manufacturer venting is used. That'll be a back and forth of how you go about getting the right vent for that approved appliance. And this is pretty common as you start to look through the different manufacturers. The lists are going to vary, and all the information you see will vary per technical data per vent manufacturer will vary per boiler manufacturer I&O. And then here's just another list. So this is a third option. You'll see they've kind of grouped the stainless steel and the PolyPro in the same chart. So as where some manuals, you may have a separate chart for approved vent manufacturers for stainless, and then a separate chart for PolyPro. Another option you may see as you're going through the different boiler manufacturers is they may group all the vent material together in one approved list. Now we'll get into non-metallic, so really around CPVC and PVC. I think that is, there's a lot of conversation around that as far as some people will use that as a vent. Other people are kind of stand off from it. There is testing requirements for anybody that certifies their product to be used for PVC, and that's in the ANSI standard. So manufacturers are having to test that PVC when they do get it approved. So they're just not putting it in their manuals. So there is a test procedure. but you will have to dig through if that's something you want to vent in. Not every manufacturer will allow you to vent in PVC. You'll have to kind of search through the material to verify if it is acceptable to vent in PVC or CPVC. And then even if you are allowed to vent in PVC, majority of the time you're going to have to start off with a CPVC starter piece, and that length could vary, but that's going to make sure that that higher temperature from the exhaust does not come in contact with the PVC for X amount. It could be 5 feet, it could be 20 inches. That will vary depending on the testing per vent manufacturer, per boiler manufacturer for that venting. So when we look here, I'm actually glad to put this together, because this is something that I wanted to talk about, and it kind of showed out here when I was gathering this information. So the top green section is actually from Centrotherm, which is a polypro vent manufacturer. It's from their adapter matrix. So if you wanted to use one of our products, right, if you wanted to use one of our amp products, our 1 million to 4 million, in their catalog, they have their adapters they're going to use. So what I noticed was, you'll see here this ISV, that's an actual isolation adapter. So that goes, you put the adapter on the back of our boiler, and then there's this isolation piece, and then you attach to the Centrotherm venting. Well, if you'll notice at the bottom, we don't have that adapter. So this is pretty common with these different vent manufacturers, is they will change and add part numbers, and then the communication between the boiler manufacturers are not always the best. So sometimes you'll see this where on one piece of literature it may have this adapter number, and then when you go to the boiler manufacturer, it's a different adapter number. So that's an area of improvement for between the venting manufacturers and the boiler manufacturers, is sometimes there's part number changes or things added that the other's not aware of, and then we got to work back and forth. So this scenario actually started tracking down this week as, hey, we need to get this ISV number added to our file and then added to our manual. But again, this is something that you may run across as you're looking to specify a certain vent material, that the adapter numbers may not line up between what's in the boiler INO and then what the venting manufacturer has. Easily worked through, but that could be an obstacle that kind of just, you're like, well, what's going on here? Really confused what I'm seeing. But if you run into a situation like that, I just highly ask that you reach out to your manufacturer's rep, and then they can get a hold of the boiler manufacturer, the venting manufacturer, and get that straightened out. But this is a pretty common occurrence, especially with all the different changes to venting and new vent manufacturers coming online, seems like yearly. We'll get into vent lengths. That is probably, like I said, the biggest obstacle when we're doing any kind of retrofit is, how far can I run? What's my equivalent vent length? So you're going to see different manufacturers will have different vent lengths. But one thing I want to point out here, right, if you look at this million BTU item in both these charts, the top chart has a minimum combustion air length of 0. So that means you don't have to have any combustion air. Well, if you look at the bottom manufacturer, you're going to have some, whether it's a little elbow and a piece. But the reason being, sometimes during testing, what manufacturers will see is, right, they'll have a harmonics noise or some kind of performance, and they've got to create some kind of back pressure. So that's why no matter even if you're doing room air with a certain manufacturer, they may require you to put a little short piece of pipe and then a 90, that could easily get you to 12 feet there. But that may be something you have to do because there could be some kind of combustion performance. So just be aware that even though you're doing room air, there may be some issues, and the way to overcome that would be to just put a little bit of back pressure on that air intake. But again, trying to point out, just not all manufacturers are doing everything the same. So you specify one product all the time, and then you move towards another, things are going to be a little bit different for you. Also, if you look at that that 1 million, you'll see one competitor here allows you to upsize to 8 inch to get a little bit longer. and then the other just has 6-inch up to 100 feet. So if you look at that million BTUs at the top list, right, you can vent an 8-inch pipe and you can get to 100 feet. But if you wanted to go with a smaller pipe, you could only go 70 feet. As where at the bottom one, the only option you have is 6 inches, and that'll get you to 100 feet. So again, certain manufacturers are going to give you a little bit more flexibility on your venting. You'll just have to evaluate, do I have room to run an 8-inch pipe? And you may have to, right? If I need 150 feet, I may have to do an 8-inch piece of vent just to get to that 150 feet. But if I don't need it, then I could downsize that vent to 6 inches, and I could, if I had to go with 70 feet, that would be sufficient for that job. Or, so those are the way that list is that the manufacturer will do testing. So they will do, they'll in the lab, they'll take pipe, they'll run it at 150 feet, they'll verify the unit's operating, and then they're going to have to do a block flue test. So what they're looking for is to make sure the unit can still safely operate at that 150 feet with X percentage of block flue, and that's how they kind of get to their max vent length. Now, what you may see too is some may say not even give you a chart. Some manufacturers must just give you a inches of water column that you need to keep in your pressure reading in your vent, and then you're kind of on your own to size your vent. So if you don't have experience doing that, you may have to work with an outside source on sizing the vent if they don't have any set references for you or pre-certified testing. Also, those type of numbers may need to be used for common venting. So if you're doing common venting, somebody would give you numbers very similar, and that's how you get to common venting, which we'll talk about more here in just a few slides. And then a third option is that manufacturer may give you an equivalent feet, like you'll see here on this last call out. They're going to give you, okay, you can't exceed 140 equivalent feet, or they're also going to give you the possibility to do your calculation yourself and give you the water column that you need to stay in. So again, depending on the manufacturer, how that vent is determined will vary. A majority, I would say you're probably in the 80% range. Majority of the high efficiency condensing manufacturers are going to provide you a pre-certified chart and tell you that 8-inch pipe can go 150 feet, 6-inch pipe can go 70 feet. That's what you're going to see a majority of the time. But you will still see on occasion where they'll just give you the pressure readings, and then you'll have to size that vent on your own. If we get into sidewall termination, this is, can cause us some issues depending on how this is installed. So what I wanted to do is, if you look at the two images at the top, you'll see the image to the left, the spacing is a little bit different than the image to the right. Right. So manufacturer to the left is saying, okay, I need to have 6 diameters at a minimum between the inlet and the outlet of that boiler vent and intake. So can be a significant distance between those two, depending on the size of that pipe that you're vented in. As where if you look to the chart to the right, they're just saying 12-inch minimum. So be a little bit closer. So again, it's going to, if we go back to, and seen this a lot of times, as you go back to, well, one product was specified. Say if I specified the product on the right that only needs 12-inch minimum, so then I accept an equal, that equal gets installed, and then the venting's not per the manual. So the inspector could come out and say, hey, this manual says it needs to be 6 diameters minimum. We're not meeting that. So again, everything that was kind of laid out over product A. And then product B is saying, hey, I need more spacing between that intake and that exhaust. This testing is per manufacturer because it's how they feel comfortable with the unit performing through testing data, that there's going to be no recirculation. So what we're trying to avoid is recirculation coming from, the exhaust back up into the intake. Also, one thing in certain climates, there's been known that especially the units get into low modulation and your plume does not push far from the wall, that when you're doing sidewall venting, the bird screen that's in that air intake sometimes will kind of freeze over because the plumes just, flue exhaust, there's moisture in it. So if it's real cold, And if the plume's not getting pushed away, those bird screens sometimes in the air intake will freeze over, which then what causes is I don't get you know, airflow to make my pressure switch when the unit goes to ignite. So that can cause, nuisance lockout, especially in cold situations, which that's when we need the boiler the most. So again, making sure this spacing is correct is really necessary for proper operation of the unit and longevity too, because you could have some recirculation between the exhaust and the intake, and the unit can perform fine. But what that's going to do is it's going to obviously damage the heat exchanger internally for longevity. So again, we want to make sure we keep recirculation at a minimal, and we're more prone to see recirculation on sidewall situations when they're not installed correctly. Well, we got two more charts at the bottom. And one thing you see here, right, you've got the manufacturer on the left is going to say, well, my spacing from the bottom to the top of this gooseneck, I got a 16-inch minimum on the one to the left with a 36-inch maximum distance. And then the one on the right, we're 12-inch minimum with a 16-inch maximum. Again, this is going to go back to per manufacturer and just knowing what you're getting into. This is probably more unit. I'm not going to sit here and say you're not going to have any issues. They're probably both going to run fine. But what'll happen is more towards an inspection. If the inspector calls this out, this could be something that gets dinged pretty easily because it's not matching the manual. If you're used to doing the distances on the left, and the next boiler you installs the one that requires only 16 maximum, then again, when the inspector sees it, he can say, hey, you're only allowed 16 and you're at 36, you're going to have to adjust that. Nothing huge at the end of the day, but again, it's going to be just at a time. It's going to be probably that installer is going to have to come back and tweak that. This is probably one of the least time-consuming things to resolve if this snorkel is a little out of range. And then one thing that's going to be pretty common is you're going to have your snow line requirement. This is, pretty, like I said, pretty common between all manufacturers. I think what's seen here over the years, when you get, especially installers, you'll get installers that'll come from one area of the country to another. Maybe, someone from the south, as they move up north, they're not used to the snow. And then this is where we've seen where that intake will get completely covered up. If this is not above the snow line, that intake gets covered up, and then the boiler can't breathe and it won't be able to operate. So not a big deal in areas where somebody's been installing, high efficiency boilers for a long time in snow environments, but it's really common, especially with all the people we have in the country moving to new areas, and just it's a new environment for them. So this is something we need to make sure that everybody's aware of. Again, that one's going to be a little bit harder to adjust, because now you're going to have to take and probably create a new penetration in a change where that air intake is actually terminating out of the building. So this is a sidewall termination here. As you can see, these are three different sidewall terminations. This is actually one of the first jobs I had been exposed to in the condensing market, high efficiency. So this was actually several 5 million BTU products that were getting sidewall. So the next image is going to kind of show you here. This building off to the right is a library for a university, and off to the left is some residential locations. So what was happening here is you can kind of see the stairway there in the middle of that circle. The stairs took you down to the mechanical room door. And what ended up happening here is these units ended up getting sidewall vented going out to the alleyway there. So the units got installed, in the fall. The startup was done, and then about a month later, it started to get a little bit colder. Multiple boilers came on, and what happened was there was a call that came in that said, hey, something's going on with the boilers. There's a fire, because there was a big cloud all the way out into the alleyway. So from the building all the way to the other buildings, the plume because they were running a full modulation, had consumed the whole alleyway, and everybody didn't know what was going on. There was calls coming in. The fire department was there. You know, everybody was nervous. They thought the building was on fire, and all it was the new condensing boilers. The plume was so big, the conditions were right, and it was just sitting right there in the alleyway. The cars couldn't get through. So that was, you know, really a lessons learned. That's pretty common when you're going to the condensing products. That plume, if people haven't experienced it, it can be pretty big. So what we ended up having to do is penetrate through the roof, and then we just shot those flue products straight up. So again, this is a lesson learned that really created a lot of unnecessary emotion, or emotions. You know, people were worried, but again, when there's cars can't drive through the alleyway, that's something to be aware of. Is that's actually dangerous, right? Because now a car can't even get through because that plume is so heavy. With kind of transition now to common venting, you can see here this is a common vent stack with multiple appliances attached to it. Again, common venting is one of those things that uh, is necessary, especially if you look in the older cities where you don't have a lot of options to go out the sidewall, or you don't have a lot of opportunities to penetrate a lot of penetration. So you need to have one breach through the structure. So that's where the common venting will come into. Now, anybody that's been exposed to common venting over the years will tell you if done properly, it works, but that means it has to be done properly. So as the common venting gets designed, you're going to see different levels of support from different manufacturers. You'll see some that are going to give you great detail in their manual as far as how to correctly connect the vent. You're going to have others that are going to direct you towards a third party and have you help design that. So what they can do, this third party, you can work with them, give them the calculations. They will get you a nice high resolution image, how that goes together. They can get you a BOM of all the material that needs to go. And then it's a third party certified vent. And that's, again, it's going to vary per manufacturer. And most of them manufacturers, the reason that you will see it vary so much is because if not done properly, it creates issues. So if you look at the image down at the bottom right, if this is a designed vent system, it's been calculated for these boilers being exactly 5 feet apart. If for some reason those boilers become 10 feet apart, those calculations completely change. So that's where it needs to be installed properly and per the drawing, per the calculations. Because if there's 190 that's changed, or if you do 245 instead of a 90, that's going to completely change that calculations, and then the system may not perform well. So that's just to be aware that in areas where common venting is necessary, we just need to make sure it's done per the calculations. Any tweak, sometimes a installer may have to work around a fire, a fire system, may have to work around some kind of other something hanging in the mechanical room. So when he takes and has to change his venting around to get around a structure, that's going to completely change those calculations. So we need to have those revisited. And the one common area that you'll see when any manufacturer is common venting, they're going to require you to do a damper or a backflow preventer. And what that's doing is that's going to prevent any flue products from coming backwards through the vent system down into a non-firing boiler. So if we go back to the drawing down at the bottom right again, if the boiler to the left is firing, right, and the boiler on the right is not, we want to seal that vent off to the unit to the right, so that way flue products do not come through that unit to the right. Because especially if you're doing room air, what happens if that backflow preventer is not there? It comes out of the unit to the left, and majority of it's probably going to go down up out of the chimney. But if not, right, any flue products could go down through this boiler on the right and then into the mechanical space. So that's why you need to make sure you have a backflow preventer on any boiler that's common vented. And a lot of times, if those will be available through the manufacturer, if not, they're going to be available through the venting manufacturer that you're working with for the sizing. Oh, we'll kind of transition to condensate piping. So off to the right is an image of our Apex high efficiency condensing boilers. You can see that the condensate lines coming out the side of the unit. They're going down into some neutralizers and then down through the drain. One question that'll get asked is everybody's like, well, how much condensate is actually coming out of these? It's going to depend on the size of the unit, and then it's also going to depend on what the return water temperature is and the firing rate of the boiler. So the numbers you see on the screen here, that's worst case scenario, that at full fire, full condensing state, you could have that much condensate coming out of one of these boilers. Very, very kind of critical to make sure that that condensate line is piped correctly, and you're using the right neutralizer. You'll see here, this is a recommendation. Do not manifold condensate drains and vent drains together. Okay, the reason being, what would happen is if somebody took this line from the top and connected straight to the one on the bottom, you're going to have too much flow, most likely, for that size of pipe, and you're going to have too much flow for that neutralizer. So most of your manufacturers are just going to say, do not common manifold them, just because there's concerns over that piping and the neutralizer being sized correctly. Not saying that if sized correctly, that's going to cause any damage. Most likely not. The concern with all manufacturers are it's not going to be done correctly in the field. So that's why they're going to say, hey, individually pipe the condensate drains with neutralizers. And then again, what do we have? Why are we neutralizing the condensate, right? Because it's very acidic. It's going to eat away at your drain line possibly. So we don't want to do a metallic pipe, right? Because what's going to happen is going to eat away at that condensate. So kind of was able to get this image here. You'll see here this is a condensate line that's been ran out of the boiler in copper, and you can see what happened, right? The copper got completely ate away. So again, that's what we're trying. That's why we're taking and we're adding that neutralizer, right, to bring that down so it's not so harmful as it goes into the drain. So why would we want to add copper piping to the connection here, and then the copper piping will just disintegrate over time? And again, this may not take long, depending on how much condensate is being produced and what kind of conditions that boiler's in. Talking about neutralizers, every boiler manufacturer, depending on the manufacturer, the size of the boiler, you may get a neutralizer with the boiler. It may be a line item for the order entry, but every boiler manufacturer will have a neutralizer. Now, there's also a handful of companies that just specialize in providing neutralizers. So on the screen now, there's two different third-party neutralizers, right? And that's what they specialize in. So you don't have to use the neutralizer that the boiler manufacturer provides. Sure, we would all love you to purchase that from us, but is it necessary? No. But you do want to if you need a neutralizer, you do want to make sure you get one. And again, there's other third parties out there, and that's what they specialize. Just like we specialize in building boilers, that's what they specialize as, is providing neutralizers. So the manufacturer rep where you're working with, they may have their own line of neutralizer, and that may be what they recommend, and they can provide you the reasonings behind why that product is better. And then we talked about, in the opening, about these high efficiency boilers getting installed outdoors more and more. And then what we're seeing is, okay, now there's people that are wanting to apply these in areas where there's freezing temperatures. So we just need to be aware of that. Some manufacturers are going to say, hey, do not install these below freezing conditions. And then other manufacturers are going to say, hey, if you do, you need to get a kit. You need to protect that condensate. So you need to be aware this is a huge difference in with the high efficiency products. Some are going to say, hey, you can install below freezing temperatures, but you need a kit. Others are going to say, no, you don't need a kit. You can't even install below freezing temperatures. So you just need to be aware of that. But there is no doubt, if you get below 32 and you're running running the boiler, what's going to happen? That condensate is going to freeze. You're probably going to be all right as long as the unit is running. So if the unit never shuts off, probably not a big deal. But once that unit shuts off and that boiler's off for any amount of time, that condensate's going to begin to freeze. And that's where you're going to run into the issues, because the next cycle with that boiler, every unit's going to have a condensate block switch on it, and that block switch is not going to make, because the whole thing's going to be frozen. So again, just be aware that if you do install these outdoors, one, is the unit certified for below freezing temperatures? And then two, if it is certified or allowed, you need to make sure you're protecting that condensate. We'll get in here to gas pipe sizing. This will be getting pretty close here to the end of the presentation. So this is what we referenced about, just because of the boiler has a 1-inch connection doesn't mean that's what you need to run for 200 feet. So if we look at this scenario, we've got, that our amp 1 million, our amp 1.25 million has a gas connection of 1 inch. That allows us to make sure we can have enough gas to get to the internal gas pipe of our unit into the gas valve, which is minimal, maybe 1 foot at the most. So when you look at the National Fuel Gas Code, and these are tables that are going to be in everybody's manual, they're going to be based off of specific inlet pressure and pressure drop. So you need to know what your specific system is, the conditions are of it, but there's multiple charts. So you may have one chart that says inlet pressure of 14 inches, and then it may have you 3 inches of pressure drop. But this is for you to determine on that gas, that gas system, how that system's functioning. But if you just look here at this 1-inch pipe, you can see we showed the previous screen that 1 inch, right? If you even go 10 feet of 1-inch pipe, you can't get to 1 million BTUs. So no matter what, you cannot connect, 1-inch pipe to that boiler. It will not have enough gas to get there in this situation. Now, it may be different if you're if you're looking at a different chart, but again, based off of this chart, that 1-inch gas connection would not be enough. They would have to go at least with 1 1/4, 1.5 inch. Also, from the National Fuel Gas Code, you'll see here is equivalent feet for different fittings. This is not going to be in every manual. Some manufacturers will show a chart like this, others won't. Others are just going to give you that previous chart that's going to show you the equivalent feet. So you would have to find out, okay, well, what is the equivalent for a 45, or what is the equivalent for a 90? There's some rules of thumbs out there a lot of people use. They'll use 5 feet, 10 feet for different fittings. But especially if your gas pipe is questionable, you really need to truly determine what that true equivalent feet is. So you probably want to make sure you get the exact equivalent feet calculations out of the National Fuel Gas Code. So we're going to run through one scenario here next. So in this situation, we're going to say we've got 2 1 million BTU input boilers. We're going to say we've got 4 2-inch 90s on the gas line, and then we got 20 feet of 2-inch pipe. So doing the math, that says we got an equivalent of 40 feet, 40.8 feet of 2-inch gas pipe. So what we're going to do is go back to this scenario where we had this gas pipe sizing chart out of the National Fuel Gas Code, and we're going to look here. Okay, so we say we got 2-inch, and we're at a little over 40 feet, so we're just going to go to the 40. So that tells us we're only good for 1.9 million BTU input on the boiler, and we said we had total of 2 million BTU input. So that means we're going to be a little bit shy. So this unit may operate without any issues, because you're really close on the border, but most likely there is going to be some issues, especially when you're firing at full fire or if another boiler comes on. But in this situation, right, if there's an issue on this site, the first thing that anybody's tech service is going to go to you and say, hey, this gas line's undersized. You need to go up. You don't have enough capacity. So that's just something to be aware of. This is a pretty common call that comes into anybody's tech service, is they'll walk through this and, they're going to say, hey, my boiler's not firing. it ignites, and then as it ramps up to full fire, it shuts off. You start doing the calculations, and you find out, well, you don't have enough capacity in that the gas line can carry. So again, this is common. This is not manufacturer specific. This is again from the National Fuel Gas Code, so you'll want to reference that, or these charts are in everybody's manuals. But this is really common. I mean, anybody that's been in the field, this is an everyday headache, if not a weekly headache. And here's that back to that picture. There's 2 units. You can see here that gas line, right, stubbed out of the unit at a small diameter pipe, and then we increase to a larger pipe, which gives us full capacity. No issues here. So they've actually, kind of followed the directions here of the manufacturer on the gas line and on the condensate line here. So that's a good install. All right, so get into regulators. So it's going to be fair to say if you have a conversation with anybody that's been doing this long enough, they have had some kind of run-in with regulator issues and high efficiency turn down boilers. From my experience, when you look back 15 years ago, a lot of manufacturer reps did not have regulators. But as they started their journey down providing high efficiency boilers, they started to partner up with regulator companies that they knew would support them and that they had the comfort in. Boiler manufacturers started reaching out to regulator manufacturer and said, hey, what can we do? What kind of relationships? So everybody started building more relationships around regulators, because what we found was they weren't responding the way we were expecting. There was a lot of nuances going on as more high efficiency boilers got introduced. So the support material that's out there now from the regulator manufacturers is better, and then also from the boiler manufacturers. Before, there wasn't a lot of guidance from any. You'd buy a regulator, really no instructions, right? If you look in the boiler manufacturer, there really wasn't a lot of directions about regulators. But that's been changing over the years. But you're going to notice a lot of differences. You'll notice differences between what the regulator manufacturer says and what the boiler manufacturer says. And you'll kind of see these as we show a couple of the snips from each one. So here, this one's going to tell you, right, it says, make sure that the gas train, is the same pipe as the equipment, right? The same size pipe out of the equipment with the same size on the regulator. This one's going to tell you, okay, you got to install the regulator 3 to 10 feet away, depending on the application. Why is that? You want to have some volume between the regulator and the equipment to make sure that the response of the regulator and the equipment can work together. So now here, this one, instead of giving you a feet distance, they're going to say what? 10 times the pipe diameter, right? And they're going to say, hey, before you do any changes, 90s, right? You need to make sure that you have 10 times straight pipe, right? And that just allows that regulator to perform better and not have any sporadic operation. Again, you're going to see here the 10 pipe diameters referenced again. And then also you're going to see the 10 linear feet between the units. So this is really good. So this is really, some of these are from boiler manufacturer manuals. Some of these are from the regulators, but it's really nice to see that we're all kind of getting working together to find a resolution to the issues that we saw early on. But if not installed properly, right, we can still see some issues. This next one, I personally struggled with one of these jobs years ago. What was happening was, right, the unit would operate, it would shut off, and then it would build up pressure on the backside of the valve between the unit and the regulator. So the unit, what you want to operate on is a maximum 14-inch water column. Well, when the unit shut off, there would be times where that, gas pressure would spike. You would get up to like 30 inches of water column. Well, under that much water column, the gas valve will never open again. So during, and I'm going back again about 15 years ago, but there was really no, we were all struggling to figure out, well, it seemed like a regulator, and we were all pointing fingers at each other. Well, it's the regulator. No, it's the boiler. like nobody knew what was going on. Well, then I'm, doing research for this presentation. I see this. I'm like, oh, well, that would have been nice, 15 years ago. That pretty much, if the regulator's not sized properly, that's what you're going to see is excess pressure. So it doesn't matter whose product yours is. If you get too much pressure up against that gas valve right internally in the boiler, it's not going to open back up. Unfortunately, the job I was dealing with, when was it happening? When it was the coldest, and it was repeated, and it would happen middle of the night. When the units went to full fire and then they shut off. So again, this is hard lessons learned. I think we're through a lot of this, but again, with regulators, if they're not applied right, we could still see a lot of issues out there, especially with the high turn down equipment. So with this, if you look here, right, we kind of saw this kind of informational stuff that, hey, keep the regulator 10 feet from the unit, have X amount of straight pipe before you do any 90s. So not even talking about anything out of the regulator. I'm just looking out of our manual. So out of our manual, it says locate the field supplied gas pressure regulator minimum 10 feet from the appliance, right? So we can say that's not 10 feet from the appliance. So again, this goes back to this may perform well, but if this is in the field and somebody calls in a tech service and having some issues as far as, hey, the unit's not performing well, what's probably going to be the first thing that's recommended? Take that regulator and get it moved out, get it moved away from the unit. So this is one thing here, again, pretty common that we see in the field from a aftermarket, after startup or during startup. A lot of times we'll see some of these regulators too close. And that may be because, they didn't have room 10 feet away or whatever. But again, this could cause nuisance problems after startup. During startup, it may work fine, but when the unit starts to operate under a load, things could start popping up on the job site. So that's all I have for the presentations. I just want to kind of cover the products. Kind of did this last time to recap. If you're looking for products that we have available in the condensing market, we have our Apex, which is 5 models. That's going to get you from 399,000 to 800,000. We've got our AMP product, which is going to get from 399 up to 4 million. And then we have our Arctic, which will get you from that 999, so 1 million, all the way up to 6 million BTUs. So that's the Thermal Solutions product portfolio. And really that should be able to get majority, even if you have to combine a couple of these larger ones, it should get you a majority of your needs you have for the condensing market. Before I turn it back over to Charlie, I just want to say, just because we're sitting here talking about going from a cast product to a condensing, that may not be always something that you can do, depending on, well, hey, I couldn't make it. I didn't have anywhere to do the condensate, or I didn't have any way to get the new venting run. So going back with a newer cast iron is not bad, and that's something that may need to be done. Again, if we have that opportunity, we go ahead. It's fine, because we're probably getting to a point here in the near future where we're not going to be able to have that luxury, right? Here soon, probably things will be put in play with an efficiency standard that we won't be able to go with the cast back to cast. We'll just have to do a high efficiency condensing product. So if your job kind of allow you to, and you still want to go back with cast, that's fine. Not all situations are going to allow you to take advantage of the efficiency of a high efficiency unit anyways, which we talked about last webinar. So going back with the cast product is acceptable also. So again, get ready to turn it back over to Charlie. But with the venting, we kind of talked about the different vent materials, kind of the headaches with all the different adapters you may see. Sidewall termination, right? I guess with that, hopefully you don't run into a situation like I did where, get the fire trucks called on you, and, you got everybody in your office wondering what was going on. Common venting, the biggest takeaway there, if you're doing a common venting job, it just needs to be installed like it's designed. Gas pipe sizing, just don't run whatever diameter that's poking out of the boiler. Don't run that. Make sure we get the regulators installed properly, because that'll create a lot of issues. And then just make sure we're removing that condensate properly and using a neutralizer when we need to. Because last thing we want to do is not use a neutralizer and tear up an old drain or something. That's going to be a pretty way more costly repair than just adding the neutralizer. So Charlie, I don't know if we got any questions that came in. While you get on and look through those questions, just kind of let everybody know we'll do a one last webinar here. We'll be talking about just the hydronic piping, kind of the pumping through the high efficiency boilers. We'll kind of touch water quality. I think we're all doing better as boiler manufacturers talking about water quality. It is a little more necessary as we move towards these high efficiency boilers because they have smaller passageways to get the efficiencies. So if we're not taking care of the water in the building, we can see some premature failures of these condensing products. And then we'll kind of talk about indirect water heating, some different ways to get there, whether it's a hot water generator or indirect tank. So Charlie, we get any questions come in?
Yeah, we had a little discussion here. I appreciate this, Dan. Thank you. Thanks for sharing all these thoughts with us. This is really, really good detail. Again, you're not going to get all that necessarily reading through all the all the manuals if you have the fortitude to actually do that. But yeah, I think something we had here was, we talked about in the first part of this series that there, is definitely some advantages to going to high efficiency products. But I think some of the things you're talking about here is that there's actually a cost, right? A cost to making that switch, right? It doesn't come for free. Right. And so I think naturally that leads us down this path of, what can we potentially reuse, right? Is there anything, with some of these atmospheric installations that, we don't have to necessarily swap out? I'm thinking of things like regulators, right? Can we keep any of those appliances, those pieces of equipment around, using with this high efficiency product?
Yeah, best practice is going to be to work with somebody that provides regulators and at the minimal you could vet out that regulator depending on how old it is, because some of them have not been tested for the high turn down. The high efficiency boilers, the valves respond quicker than your atmospheric units. So not to say you can't use an existing regulator, but odds are it's probably not going to be one that's going to perform well with the high efficiency product. So you could go through the exercise of trying to vet that out, or maybe simpler just to source a new regulator and put it on there and feel comfortable with that decision. But I'm sure there's situations where there may have been a new regulator installed recently and it is compatible with high turn down, but you would have to do that research.
Yeah, got it. Yeah, and there's some discussion here in the chat around polypro. Is it a brand or is it referring to the generic name of polypropylene? So I think we got that one answered in the chat there, which is a great. Yeah. I appreciate everybody chatting in there.
Yeah, and that one's yeah, and back to new vent manufacturers. There's been several new non-metallic polypro, those type of vent, those type of products coming out, that material. And again, that's where all I can say is if you talk to a salesman or somebody that's trying to provide that vent and they have I would just say, hey, get with the local manufacturer's rep or send an email into us, the boiler manufacturer, and because it may not be in our manual, because it seems like, again, we've got more people getting into the venting manufacturing. And I would expect more to, especially as we start to see more transition towards high efficiency products. The boiler industry, the furnace industry has already went to high efficiency, but there's just going to be more and more players getting into that. So that's something we'll have to keep up in our manuals to make sure they're in our files and certified.
Gotcha. Yeah, in terms of that, kind of along the same lines, in terms of condensate neutralizer, I mean, do boiler manufacturers typically have an opinion about the type of neutralizer that's being used, or any brands within that, or is it really just best to refer over to manufacturers' reps to make sure it's specified correctly?
Oh, yeah. So all your boiler manufacturers will provide a neutralizer, right? As far as it may not be provided with the boiler, it may be an optional accessory, but we will all provide one, and we'll make sure that it's sized properly, right? It'll be sized for It may be a little overkill because we may do a range from 500 to 800 or 500 to a million capacity, and we kind of lump it all in there. But something can be sourced. Um, Now, is it the best neutralizer? Depending on your feelings on neutralizer, you may feel like there's another one out there that you want to use, and that's fine. But there will be something available through every boiler manufacturer. But back to your point, Charlie, about the manufacturer's rep. Again, our manufacturer's reps, they're repping a boiler line. A lot of them are repping a regulator line. They also offer some of them offer neutralizer. So, you can work with them, and they can try to help you provide what you guys believe is the best package for that job. You know, I'm not sure if any of our sales team is on here. They may kill me, but right. I mean, I'd rather you work with us and get the boiler, and if you get the condensate neutralizer for somebody else, that's fine.
There you go. Well, good. Well, I think we are just at time here. So, Dan, I appreciate again sharing all this knowledge. I appreciate all of you on the webinar here today, joining us here. And as always, we'll be sharing this information after the fact. Whether you registered and you made it, or you're couldn't make it but you registered, we'll send that out either way. But again, one more time, I just want to give a plug for one more series. There's still more to talk about in terms of casting condensing. Some really important topics here that Dan's got here on the screen right now. We want to make sure we have the ability to share even more information and experience with all of these elements of making your switch from cast iron to high efficiency condensing. So I appreciate everyone on the call here today. And thanks again, Dan, for your presentation, and looking forward to seeing you next time. Thanks, everybody.
Thank you.